So, make sure you have out your green packets and you're at 1.3. We just have 2 pages of notes to do, but we're going to have lots of graphs and a lot more calculations to do today compared to the last couple days. 1.3 is the second day and the last day that we're going to graph categorical data. Yesterday we talked about pie charts and bar graphs. We're going to continue more graphs with categorical data, but today specifically we're going to look at what we call two-way tables and categorical data, where we start to take data and compare two different classifications or two different categorical variables with each other. And what happens is you can start to take a look at, for instance, I could take a look at gender and grade at the same time on a set of individuals. And I can start to break it and organize the information. So I can create what's called a two-way table. So I could do something like this, where I have males, females, and then I could talk about seniors, juniors, and sophomores. And then have counts for them. So like 20, 10, 5, 15, 20, 10. Just making up some random numbers. But that's what a two-way table will look like. You'll have two pieces of categorical variables that you're analyzing at the same time. Once we get that two-way table, we'll want to start to make some calculations. Okay? One type of calculation that we'll take a look at is what we call marginal distributions. Okay? Basically, a marginal distribution, what I like to look at it is, it's parts of the whole, is what I like to think of it as. Parts of the whole. Meaning, you'll start to calculate out, okay, percents, and it's best done using percents, as it says here. For instance, I could take a look at my table here, and if I look here, I can start to do some totals. And I didn't make enough room here, but I'll kind of squeeze it here. Here I have a total of 35 males and a total of, 45 females? 45. And here, like seniors was 35, 30, 15. So if I add those all up, I think I have a total of 80 on the people on my table. When I'm doing marginal distributions, what I'm basically doing is I could do it one of two ways, and it always depends on the problem. So I can start to take a look at percentage that are male or percentage that are female, percentage that are seniors, juniors, or sophomores. So it's comparing parts of the whole. Meaning if I wanted to do just males and females, I'd go 35 divided by 80 versus 45 divided by 80. So if I pull up my calculator real quick, I just need to do one of them. 35 divided by 80, 43.75%. So I could say 43.75% are males, while 56.25% are females in this table. I could do the same thing for seniors, juniors, and sophomores and take a look at those distributions. So marginal distributions, again, parts of the whole, because we're going to talk about conditional distributions in a little bit. So to give you more practice and so that you can see this a little bit better, here's our example that we're going to use throughout our problem today. It says here, a sample of 200 children from the United Kingdom, ages 9 through 17, was selected from a Census at School website. The gender of each student was recorded along with which superpower they would most like to have. Invisibility, super strength, telepathy, ability to fly, or ability to freeze time. Here are the results below. So we can say how many females and how many males and how many total prefer invisibility. Same thing for super strength. telepathy, flying, and freeze time. We can see how many total females there were, how many total males there are, and again, our table total right here. So, in part A here, it says use the data in the two-way table to calculate out the marginal distribution in percents of superpower preferences. So here it tells you what percents you want to actually calculate out. You want to focus on superpower preferences. Okay? So I'm going to calculate out all of these percents right here based on their superpower preferences. If it said gender, I would be looking at these percentages here. What percent would be male and what percent would be female. So to get the percentages, I'm dividing each of these numbers right here by the table total. So in essence, I'm just dividing each of these by 200. Now, depending on how strong your, mental math is, okay, and your number sense is, we could actually probably get all of these rather quickly without using the calculator. Because we know percent is out of 100. If I'm dividing by 200, what would this 30 actually turn into as a percent? 15%. You'd actually just divide it by 2 and make it a percent. So 20, cut it in half, 10%, 22%, 54 divided by 200 is 27%, 52, 26%. These are the marginal distributions of superpower preferences. So we got those. Nice. So now, once we have those percentages, it asks us to make a graph to display our marginal distributions. Describe what you see. So this is basically what we were doing yesterday. So you can actually make a choice of either doing a pie chart or a bar graph. I think bar graphs are a little bit easier to do. No. No. Because you actually, and you did it by numbers. So when we do bar graphs, most of the time we're doing it by percentages. Okay? So it's all right. We can cross it out and put it down here. I'm going to do this to my screen just so that I can see the percentages and be able to draw at the same time. So B, make a display. I'm going to do a bar graph. Okay. Emily, right?
Yeah.
Wow, I got a name.
So do we have to get our own calculators, or can we check them out?
Yes. The answer with the calculators is either get a TI-83 or 84, or you can go to the library to check it out. I know one of my students in second hour did today, so at least they still had calculators as of this morning. So now getting back here, we need to label, so I like to put it on my superpowers. And then here will be percent. Now, when I label my y-axis, I want to, as much as possible, use the entire y-axis. So I'm going to look at my percentages here. Note that my highest percentage is 27%. So I might count by fives going up to about 30%. So let's see here, if I go 5, 10, 15, 20, 25, squeeze 30 there. I'm sorry, question? Thought I heard someone say why. But again, you could count by different values, but try to use the entire y-axis so that you can actually see a difference between the bars. So now I'm going to use symbols for each of these. I for invisibility, SS for super strength, T for telepathy, F for flying, and FT for freeze time. So we can start with invisibility. Invisibility was 15%. Then super strength was only 10 SS. %, was telepathy, so that was T. 27% for flying. I can fly. Freeze time. Have you ever seen that show Heroes?
Yes.
Didn't one of them wasn't his name like Hero
Yeah.
on it? He could freeze time. That was kind of a cool one. Oh, I need a title, don't I?
Which I would assume would be overpowered.
So I might be like saying superpower preferences. Now it has that fun word here that pops up from time to time. Describe what you see. So we got to write a couple sentences talking about the superpower preferences. So let's see. It's United UK students age 9 to 17. So I just want to make sure I know what my individuals that are being described here. So what superpower do they prefer the most? Flying followed by freeze time, and then maybe I'd say telepathy. So I'm going to write a sentence including those three. I want to make sure I include all 5 of them. So I'll say kid or UK, since it's United Kingdom kids age 9 to 17 prefer, what was it first? Flying first, then, then freeze time, and telepathy. Then I might say the least preferred superpower was super strength, followed by invisibility. So the key thing is when it, again, talks about describing, you want to write a couple sentences and you want to make sure you include, all of, in this case, all of the different categories or our superpower preferences. Boy, I when I look at the superpowers, I always struggle. Which one would you prefer the most? I'm between the two highest, flying and freeze time. Flying would be so cool. Okay. Those super strength would be kind of cool too, to be able to lift things, but to just be able to control that. Because I'd go like this and I'd knock you across the room. That'd be scary. All right, any questions so far? Wow, we're cruising. Asia.
What would you do if you froze time?
What would I do if I could freeze time?
Literally anything.
Wow, great question. Like, you could freeze time. Oh, I don't know. I have to think about it. Like if I'm a big sports fan, right? And if I could go back and freeze time, like back in 2000, what was it, 2009, when Brett Favre threw the interception to the New Orleans player. I could freeze time right before that interception, move the New Orleans player out of the way, and unfreeze time, so the pass either A gets completed or it's an incomplete pass, and maybe we kick the field goal to win it. Okay? Or I freeze time back in, 1999, when the Vikings lost the missed field goal that would have just sealed the game. I could have maybe froze time, moved the ball over so that it actually goes through. A little bit, yeah. But not as much as I used to be. So we used to have Viking season tickets in our family, and because of the new stadium and how much they're charging, we just said no thank you. They're charging way too much. Our season tickets went from $2,500, roughly about $2,700 for the season. For if we want them in the new stadium, $6,000. And that didn't include the $9,000 one-time seat licensing fee. So for the first season, for our tickets in the Viking Stadium, if we were to have kept them, would have cost our family $15,000. Insane. And that's now going to be video or going to be recorded. What's that? To watch? Yeah, exactly. To watch them break our hearts for yet another season. So I'm guessing, Elder, you're not a Vikings fan.
It depends.
It depends on who they're playing. Are you a Packer fan? Oh, she's not even saying. Oh!
Jordy Nelson.
Ouch. Yeah, that hurts. But all they have to say is Super Bowl, and we're done. So, all right, let's continue on to the next page. We can continue to talk about. One of the things that I did to help us out a little bit, you don't necessarily have to write this up here, but I put this up here because in our next example, they're going to refer back to this table. And so flipping back and forth, at least on the screen, is kind of a pain. So if you're wondering where all these numbers are, this is just a copy of the counts from your table on the other side. I just moved it in the other direction. So how many males preferred invisibility, super strength, telepathy, flying, freezing time, so that we have it. So now, the second type of distribution when given a two-way table that you'll be asked to take a look at is what you call conditional distributions. Okay? Basically, when I think of conditional distribution, I'm calculating out percents of the parts. Okay? Or sometimes I look at it as parts of parts. Now, what I mean by this parts of parts, okay, is we have a condition. We have we're looking at specifically one group or one of the classifications of the categorical variable. So what I might ask is, what are the superpower preferences for just males? What's the superpower preferences for just females? Those would be and I could look at the percentages, and those would be my conditional distributions. Okay? I could also say, well, what's the distribution of males and females just on invisibility? So what percent of males prefer invisibility versus females that prefer invisibility? And I'm just looking at that. So there's two different ways that I could do the conditional distributions. Being able to know which one is which is important. Now, what happens is with conditional distributions, you're now going to start to compare groups of people or or different categories, and you're going to kind of start to compare them. How we graph those comparisons visually is by doing either what we call a side-by-side bar graph or a segmented bar graph. A side-by-side bar graph. What that will look like, just to kind of give you just a small little picture, is you'll have, a little category here. Maybe I'll just call it A. And you'll put both graphs here, but you'll have, a difference between the two. So I just thought I'd color them a little differently. And you'll do the same thing for B. So B might look something like this, okay? And you'll continue to do that for all the different conditional distributions, kind of like that, yeah? The other one is called a segmented bar graph. A segmented bar graph will do the same thing as a side-by-side, but what happens is you'll have the groups that you're comparing, and what will happen is you'll have on the x-axis, you'll have your percent, and on the y-axis, you'll have your groups. So you might have group A and group B here. And then what will happen is you'll graph the percent of preference within each. Meaning, like in A, it might be only this small percent, while B, it's this big. But then with the next one, A might be really big, and B might be really small. And C, okay, might be like this and like this. Okay, and we can keep on doing it for all the different colors. The nice thing about the percent in the segmented bar graph is this percent goes to 100%. Now these are just kind of rough pictures of them, okay? They're not the exact ones, okay? But we're going to do a graph of, we'll give you an example of a side-by-side and a segmented bar graph, one of each, from our superpower preferences here. Are you okay if I go to part C right now? Just want to make sure. I know I did a lot of drawing up there, so I can easily pause and wait for a second if we need to. All right, in question C then, it asks, here it says, from the superpower data, that's why I put it up here, it says calculate the conditional distribution of responses for males and females. So what I want to do is calculate out the percentage for males for all 5 different superpower preferences. So I'm going to have here invisibility, super strength, telepathy, flying, and freeze time. Now to get the conditional conditional distribution, I need to get the percents, and I'm only concentrating on males. So what I'm going to do is I'm going to take each count and divide it by just the total number of males. So for invisibility, I would start by going 13 out of 85. And I'd calculate out that percent. If you trust me, I'll do it on the calculator here for the first one. 13 divided by 85. And we get 15.3. I'm just going to round to the nearest percent because it doesn't have to be exact. Because with the graph, we're just going to get a good picture of it. So this is about 15%. Let me move this up a little. Well, I better not. So the next one, 17 out of 85. You trust my calculations from when I did this before. That was 20%. Telepathy was 5 out of 85. Which is 6%. Flying was, let's see, 18 out of 85, 21%. And then freezing time was, wow, 32 out of 85, which was 38%. Now one of the things I actually do is I'll kind of check and add these up just to make sure they should add up to 100%. They could be 99 or 101 depending on the rounding issue, but 15, 20 makes 35, plus 6 is 41. Right? That makes 62, and 62 and 38 is 100%. Now I asked to do it for both genders. So I also need to do female. Now with the female, I'm not dividing by 85, I'm dividing by 115. So I have to do each of these by 115. I start with 17 divided by 115, which is about 15%. Then 3 out of 115 still stays at rounded up, goes to 3%. It's actually less, but rounded. So 39 out of 115, 34%, 36, 31%, and 20 out of 115, 17%. Do you need me to zoom in on those percentages a little bit? Yeah, I can do this. Does that help?
Yeah.
Since I don't need the table anymore. So now, part D, am I going too fast? Part D asks you to make both side-by-side graph and a segmented bar graph to display the conditional distributions. So I'm going to do both of them in this space. So I'm going to try to do like half and half. Are you okay if I go back to 100% here a little bit so that I can see the data and the screen, and if I need to zoom in, I can? Okay. So I'll go side by side here. Let me just switch colors. I'm going to do side by side. I'll do that here, and I'll do segmented over here. So if I'm doing a side-by-side bar graph, what I'm going to actually do is I'm just going to put the title right in the middle. So title here will be Superpower Preferences by gender. So a side-by-side bar graph, x-axis, y-axis. So we're going to have the superpower here. And when I look at all my percentages, what's my highest percent for any of them? Let's see, we have 34, 38. So I'm thinking I want my graph probably to go up to about 40%. So I'm going to count by 5, so this will be percent. So I'll go by 5s. 5, 10, 15, 20, 25, 30, 35, 40. I started spacing that a little bit. So I'll write those in, 5, 10, 15. So this is the busy work of it. So now, superpowers, I had invisibility, I had super strength, I had telepathy, I had flying, and I had freeze time. So what I'm going to do is I'm going to color code my bars, blue for male and red for female. So under invisibility, what's going to happen here is I'm going to have 2 bars going up. Okay? And same for super strength, but it's all based on whichever percentage. So I'm going to do all the males first and then connect all the female bars to the males. So let's see here. Invisibility was 15. So notice how I'm not taking the entire space. I'm trying to take about half of the space that's under invisibility. Super strength, I'm going to 20%. Telepathy is only 6. 21% for flying. And freezing time, 38%. Boy, it must be all the guys that want to do what I do with the Super Bowl or something like that.
Yeah, totally.
You could make lots of money, right? You could dictate the scores of games and stuff like that. Wow. All right, now we're gonna do all the bars for females. So 15%. 3% for super strength. 34% for telepathy. 31% for flying, and 17% for freeze time. Every time I think about freeze time, I always think freeze rate, freeze rate, freeze rate. Despicable Me. I like that movie too. Oh, with the Minions one? Minions wasn't. I haven't seen Minions. My daughter loved it. My wife and stepdaughter said it was just okay. I thought I'd really like it, but I didn't get a chance to see it. So now, how are we doing with side by side? Are you okay if I start doing the segmented? Actually, before I do the side by side, one of the things that I'm going to do here is kind of just note a little key. So I know that this is female and male, so that you can tell the difference between the two. Lots of times what I would do is, if I don't have like 2 different colors pens and pencils, which many of you might not, I might shade one and leave the other open. What becomes the challenge is the segmented one makes it a little more challenging. So now, I'm going to move on to the segmented one. So with the segmented one, things change up. Because what happens down here is, I like to have the x-axis be percent. Now, the nice thing about these graphs is you can actually flip the axis. You could have superpowers be here and percent be here and have all your bars going horizontally. Same thing here with the segmented graph. I'm going to have it go horizontally, but you could have it go vertically. Okay. So this is the percent. So the percent is going to calculate all of them. So what I'm going to do is count by 20s here and go 20, 40, 60, 80, 100. What I'm going to do is I'm going to create, of course it helps if I put an extra 0, 2 bars here. And I go ahead and make this entire bar. The top bar I'll put as my males, and the second bar will be females. Could you flip those around? Absolutely. So now, what I'm going to do is each superpower is going to be a color for me or a shading of some kind. Okay. I'll color code it nicely, but you could do, shade it all the way in, leave it open, do dashes, do like stars or circles in it, polka dot it, so that you can have all sorts of different values. So I'm going to start with invisibility. So I'll make that green for invisibility. I'll just at least write it. I won't write out the whole word since I don't have the space. Both of them are 15%, which is kind of nice. So I estimate out 15%, estimate out about 15%. The idea is to give you the overall picture of their preferences. Now this is where the fun begins. You might be going, oh, I don't know if this is fun, Mr. Bartz.
Hey Bart,
Yes.
why'd you do a different scale of numbers for the percent instead of going by bars?
Here, I could. I just didn't want to write 5, 10, 15 all the way up to 100. I have to go up to 100% because I'm going to account for all of these percents in my graph. Does that make sense? Yeah. So now, the second one was super strength. So what has to happen is from the end point here of where it's males, I need to add on an additional 20%. So 15 plus 20 means I'm going out to about the 35% mark. Oh, I get this value. However, for females, I'm at 15%. I'm only adding 3 more percent. I'm just adding just a tiny sliver. Okay. So notice how 15 and 20%, so I'm up to about 35%. But for females right now, I've only counted between the two 18%. So that's how I kind of gauge how far I need to go. Let's see, we can go, let's go purple. We keep on going, telepathy. So now I'm only adding 6 more percent. So 35 plus 6 is 41, so I'm just past 40, so I get just a little sliver. However, for females, I'm going to be now adding 34 more percent. So I've accounted for 18 and 34 makes 52, a little bit over halfway. Bless you. Let's see, I'm going green, red, purple. Should I go orange? That would be a good color. We don't use orange very often. So now we're talking about flying. So males is 21%. So let's see if I've counted for 41, so I'd be just a little bit past 60. Actually 62 to be correct. And then I need to add 31%. Wow, I've already accounted for, I think it was 52 and 31 makes 83. So I'm all the way out to here. And then I just have one more color. I haven't used blue yet. So that will be freeze time. So that's what a segmented bar graph looks like. It colors in the percentages of the superpower preference for the females and the males, and the colors match up the superpowers. So you can now start to see what is preferred by each gender, by either graph. All right. Do you need a second yet to work on these graphs? I'm hoping I was going slow enough that you were able to keep up. Do they make sense?
Yeah.
Okay. Many times, once in a while you'll be asked to do a graph, but many times, like in your homework assignments, they might ask you to do one here or there, but lots of times they'll give you the graphs and start to ask you to interpret the information. And that's what question E does here at the end. And if it was a little small, I'll change the width so that you can see it a little bit better, nice and big. Okay. So, in question E, it says, based on the survey data and using your graphs, can we conclude that boys and girls differ in their preference of superpowers? Give appropriate evidence to support your answer. Okay? So do they differ in superpower preference? For the most part, yes. So I'm gonna say something like that for the most part. Yes. Which ones did males prefer more than females? Freezing time and super strength. So I'm going to note this. Males preferred R-E-D. It's P-E-R, preferred. Preferred freezing time and super strength more than females, while females preferred telepathy and flying. More than males. I am going to just note invisibility. So they both equally, oh, I hate it when I forget letters. They both equally preferred invisibility. Notice now how not only did I answer the question, I'm giving support and I'm including, and I'm trying to, as much as I can, include all of the superpowers or all of the pieces that I'm analyzing or that I have data on in my answer. All right, any questions so far with the notes? All right, let me stop the video.